Hello and welcome to York Universe, the astronomy and astrophysics radio podcast written and presented by the students, faculty, alumni, and friends of York University. You'll find us now wherever podcasts are distributed. I'll be one of your hosts this evening, Dr. Elena Hyde, and I'm joined tonight by two York Universe firsts, Paul Mackin and Majid Naji. We'll be introducing them later on in the show. We are, in fact, broadcasting live from the Allan Carswell Observatory located at York University in Toronto, Ontario, Canada. Just as a reminder, York Universe broadcasts live every Monday night at 9 p.m. local Toronto time or Tuesday morning at 2 a.m. UT, if that's more your speed. We are doing a little bit of a dual show, of course, broadcasting live on YouTube with our York View Observatory program in concert with the online public viewing. That's right, online public viewing run by the observatory team. So that's what you're seeing if you're watching live on YouTube. To navigate to the live show or to find out more, you can always check out our website, yorku.ca/science/observatory, and follow the links to online public viewing. Or, of course, you can click on any of the YouTube links on our site. It'll take you to our channel. For the podcast, you can find the podcast broadcast out wherever podcasts are distributed on the Wednesday latest. So that is the recorded version. For any questions, comments about past shows, or suggestions for future topics, you can email us at observe@yorku.ca, and you can also connect with us over on social media on Instagram at YorkU Observatory and Facebook at Allan Carswell Obs. All of our programs are free, but if you would like to make a donation, the observatory would, of course, appreciate it. And that's on the same website we mentioned before, yorku.ca/science/observatory. Our crew is monitoring the chat room for questions and, of course, posting content while the broadcast goes ahead. And we're going to be looking at the current weather. It is actually pretty terrible. So it looks like tonight the telescope will be staying closed and you'll be able to enjoy beautiful archival images from the online public viewing team on YouTube. And of course, if it does clear up, we'll try to open up that telescope for you. So now to get on to the fun part of the show, I get to introduce two amazing York Universe firsts. So first of the firsts, we have a special guest. Our special guest this evening is none other than Majid Naji. You might have actually heard about him earlier over on the Astronomer in Residence program. That's right, he was actually one of our whole crew from 2024. He's an active and enthusiastic amateur astronomer, and Majid has a PhD in electrical engineering. He's also a senior scientist over at OZ Optics Ltd. And he's been studying astronomy and doing a lot of amateur astronomy for quite some time. So Majid, why don't you go ahead and say hi?
Hi everyone. Thank you very much, Elena, for introducing me. Yes, I'm very excited and happy to join you tonight, and hope we could have some nice chats and for me reviewing some of the greatest memory which I had when I was in the in Killarney Observatory and the Killarney Parks.
Absolutely. And of course, we'll be doing most of the Killarney part in the second half of the show. We will do a little bit of This Week in Space and Astronomy just for the first part. And of course, you'll be able to comment on all of that as well. So thank you for coming in today. And it's great to have you on York Universe.
Thank you very much. I appreciate it.
Excellent. Now, we do have another special introduction to make, and this is not necessarily a guest, but a new co-host. Paul Mackin, who's been an observatory volunteer and member and work study student, and I believe calendar editor, and all kinds of things all around the observatory for some time now, is now joining us over on York Universe. So, Paul, welcome to your first York Universe program.
Thank you very much, Dr. Hyde. I'm thrilled to be here. Yeah, I'm a second-year student in the Department of Astronomy and Physics at York, and having a facility like the ASEO is just phenomenal, and it's so exciting to work there and be part of this podcast. I look forward to contributing today and in the future. Thank you.
Wonderful. All right, so we've had a lot of great introductions and we have a lot of great things to get to today. So let me go ahead and get us started before we get too distracted. Of course, the weather is terrible, so we are not able to observe tonight. But one thing you can do to get away from the weather is, of course, to launch a spacecraft. So I'm going to take us back in time. This week in space and astronomy history, we're going to look at a very famous spacecraft that was launched January 14th, 1986. In this year, one of the most famous images ever captured by a spacecraft was obtained. It was none other than Voyager 2, which had been cruising along for some time, and it managed to fly by the planet Uranus. On January 14th, 1986, this famous image of the planet Uranus, of the very unfortunate name, didn't start off with that name, just as a little side, and one of the only flybys, well, the only flyby, is so far the only, first and only human craft to actually visit the planet. We've had some wonderful imaging from JWST recently, but this wonderful spacecraft swept by Uranus in 1986, the solar system's remote seventh planet. Voyager 2 came within about 50,000 miles or 81,000 kilometers of the icy blue-green cloud. And of course, the image that you've seen in most of your textbooks, or all of your textbooks really, if they used real images, were the Voyager 2 images of Uranus. Uranus was, of course, discovered by Herschel, and that's probably an episode for a topic for a different episode. But even just this one glimpse that Voyager 2 was able to afford us gave us so many wonderful discoveries. Data from Voyager 2 showed us that the Uranian day is just 17 hours and 14 minutes long, despite it being quite a bit larger than Earth. And of course, Uranus's atmosphere is similar to other gas giants, hydrogen and helium, but there's water, ammonia, and methane ices. So the cosmic meetup was really a great success. And we already knew a lot about the planet based on Earthbound observations. We knew from previous telescopic observations, not just Herschel, but lots of folks, and this planet is not quite like other planets. It has a very unusual tilt. Its magnetic field is tilted a full 59 degrees away from its axis of rotation. This is really odd. This is a much bigger difference than you might expect. This means that the whole planet of Uranus has a non-uniform magnetic field. It can be very, very strong in some places and very, very weak in others. So it has radiation belts, and they can be quite intense, but it can also have what are basically gaps. It has two main belts, and of course, Earth will also have radiation belts. You might have heard of them. On Earth, we call ours the Van Allen belts for their discoverer. The Voyager 2 not only met Uranus, but provided some of the very best images of its many, many moons. We still don't know exactly how many moons Uranus has. We discovered 10, I think, in the Voyager 2 data. We have about 10. And that meant that at the time, there's about 15 moons known. And as we're able to see better and better images, of course, with the help of the JWST, the James Webb Space Telescope, we're able to see even more moons and get better data. Today we know of 27 moons orbiting Uranus. Of course, we have lots of interesting moons that we could talk about for ages. That's not why we're here, though. We're here because Voyager 2 did this amazing flyby all the way back in 1986. And the discovery of Puck and Miranda, or no, sorry, Miranda was discovered by Kuiper. Voyager 2 discovered Puck. And Puck is an interesting one. It's only about 100 miles or 160 kilometers in diameter. These types of very small rocky objects can be really, really hard to see from a large distance. Like, of course, an Earthbound telescope would have to have if it was trying to look for moons. Of Of course, Cooper found Miranda, of course, I should say that correctly. And this is the one that has a really strange patchwork, almost like appearance. It has what looks like patches on its surface, probably some kind of ice. Very, very interesting stuff. And of course, Uranus has rings, and the Voyager 2 survey found new rings. So brought the total number of rings around Uranus to 11, and increased our knowledge greatly. Of course, Voyager 2 did a lot of other things, which we won't have time to talk about today, but increasing the knowledge of this planet and then leaving behind for one final rendezvous with Neptune in August of 1989 before it headed out of the solar system. In December of 2018, NASA announced that Voyager 2 had actually entered interstellar space. So it's still going. Now it's more than 40 years after it launched from Cape Canaveral in 1977, and the spacecraft is over 12 billion miles or 19 billion kilometers from home. It is very, very, very far away. It's so far at that distance, the sun isn't even a particularly bright star. And of course, as it goes out into the great unknown, we can look back on its wonderful images of Uranus and the Uranian moons and all of the information that it gathered for us, because Uranus is not a particularly bright planet. In fact, it took a telescope to discover it. It's not really naked eye visible. It's very, very far from the sun, and of course, more than 20 times the distance between the Earth and the sun. But the bottom line is this really fun encounter with Uranus happened all the way back in 1986, and Voyager 2 is still the only spacecraft to ever have visited this strange, frigid, knocked on its side, um, really interesting world in the outer solar system. So give a little thought to Voyager 2 today as we think about interesting flybys. And this time, long time ago, it was flying by Uranus for the first and so far only time. So, Paul, I guess I'll pick on you first. Do you have any favorite Uranus or Voyager 2 moments?
Yeah, actually, it's interesting as you were reading that, I remembered. I'm a bit of an older student, and I remembered that when this happened, Scientific American published an article on how NASA and JPL re-engineered the spacecraft, honestly, on the other side of the solar system, to be able to actually do that extension to the mission, because light levels were a lot lower, the spacecraft was older, it had problems, and they had to go through this entire redesign of the software on the system to allow it to take those pictures. And the pictures were spectacular. And then, of course, they did it again when it was even further out at Neptune a few years later. Yeah, it's very exciting. And the Voyagers have continued to leave us in awe. And they're still going, not quite strong, but they're still going. That's fantastic.
Yeah, absolutely. And as you say, they was I think 1978. They did have that point where they switched. They had to switch from the primary radio receiver to the backup radio receiver on Voyager 2. And after that, the primary receiver actually completely failed, and they had to set a precise frequency for radio transmissions because the backup receiver had a failed capacitor. So it could only receive transmissions in a very specific frequency band. And that frequency would be, affected by Earth's rotation. So there was all kinds of, as you say, really, really interesting problems to solve. And it is one of those missions that has returned us just so much amazing data. And I for one, would love to see some more icy outer solar system pictures.
Well, NASA's talking about a return to Neptune. It's still very preliminary, but I think the decadal priorities survey indicated that Uranus was a good target. But I
Oh,
guess
yes.
I'll move. Yeah, but I guess I'll move on to also this week in history.
Oh,
Sorry,
let
go
me
ahead.
just
Yeah.
ask first if Majid has anything about Uranus that he likes to. Do you remember
Sure.
this mission at all?
For sure, for sure. So, you know, when the Voyager passed there, I was a very young student, so I remember that time and all the news is around. But something which is interesting for me is the magnetic field of the Uranus. Because as you mentioned, it has a big angle with its rotation axis. It's about 47 degree, and it causes a lot of fluctuation, which they, when they measure, they saw sometimes that the magnetic field of the Uranus is something like the strength is somehow like Earth, so it's about 1 Gauss. But in some location, as you mentioned, it's become zero point 0.1 Gauss, and in one part it's become about one Gauss. So it's something like 10 times variation in magnetic field in the surface of the Uranus. And something which I try to imagine that if we are living in Uranus somewhere like, you know, let's say near the equator, and if any kind of the solar activities happen, especially the big one, even the people who live in the equator have a chance to see the aurora, some kind of the, you know, those polar caps, because they also have the polar caps, like what we have for the Earth because of the magnetosphere. So something which I could imagine or, you know, to share about the Uranus is that if we live there and live in the same the latitude as here, we have a chance to see aurora, I don't know, maybe a couple of times at least per month or per year at least.
Yeah, it would be a very, very strange place to live for
Yeah.
many reasons.
Yeah.
But the highly variable magnetic field is a really interesting one. And this is one of the ones that I do hope they go back and study as well. You're absolutely right. So thank you, Majid, for hopping in. And of course, we have a lot more interesting events that have happened out in the solar system. So Paul, this is over to you.
Thank you so much. Yeah, I think I'll may add one final comment to the Uranus story. Of course, it is an unfortunate name, and everyone jokes about it. But you alluded to this, Dr. Hyde. The original name, which I actually kind of prefer, was George, which I think is quite funny. Uh,
I think it's
anyway,
Georgium Sideris. Georgium
yeah,
Sideris.
yes. Um, and named after King George, I think the third it was an attempt to get basically some money out of the king through a royal grant. So also this week in space history, on January 19th, 2006, the sorry the sorry on January 12th, 2008, NASA's Messenger spacecraft made its first flyby of the planet Mercury. Now, it was launched in 2004. Messenger was designed to orbit Mercury, but it's a complex planet to reach, as you must be going slow enough to be captured by Mercury's gravity without a huge fuel expenditure. Because it's so close to the sun, any spacecraft going in that direction is accelerated by the sun, and so it's generally going very fast. So to orbit, it's necessary to do flybys of Earth, Venus, and Mercury, which allows you to shed some velocity so that eventually you can fire your engines and go into orbit. So Messenger made one flyby of Earth in 2005, two of Venus in 2007 and 2008, and three of Mercury before going into orbit in 2011. As close as Mercury is comparatively to Earth, it took 7 years to settle into orbit. That's, you know, it's a very long journey. Also, this week, on the other end of the solar system, uh, we launched on January 19th, we launched the New Horizons spacecraft towards the dwarf planet Pluto. Now, New Horizons completed a flyby of Pluto 9 years later, and it had a gravity assist of the planet Jupiter along the way. Now, it's important to consider the relative distances from Earth to Mercury and from Earth to Pluto. Mercury is 77 million kilometers away. Pluto is nearly 6 billion kilometers away, almost 100 times further away. Mercury took 7 years, sorry, Messenger took 7 years to get to Mercury, and New Horizons 9 to Pluto. And that really, if you think about it, it's 100 times further away. That appears quite strange, but you have to think of this from a flight dynamics point of view. The missions had very different outcomes in mind. Messenger wanted to go in orbit around Mercury, which involved matching speed with the planet and then adjusting its velocity just enough to put it into orbit. This is tricky, and you have to be going just the right speed if you want to do this with a rational amount of fuel. The Pluto mission was a flyby. Its goal was to get there fast and gather as much data as possible as it passed the dwarf planet and its moons. Once you were on your way, allowing for gravity assisted Jupiter, and I think it ended up passing Jupiter as it came out of the gravity assist at about 15 kilometers a second. It was going fast. It was just a matter of getting there as quickly as possible. Given the huge distances between Earth and Mercury and Earth and Pluto, it's somehow hard to reconcile how similar their flight durations were. It also shows the differences between flybys, which are relatively easy to do, and orbits, which are much more complex to do, and how it's different dealing with operations close to the sun and far away. So that's my contribution for this week in space history.
Wonderful. And of course, Mercury was also critically under-imaged when this mission happened. The previous mission, I believe, was Mariner 10, and it had something like 40% of Mercury's surface. And so, I mean, this was another case, actually, both of your objects, Messenger with Pluto and make sure I get the right ones here. Messenger for Mercury and of course your Pluto mission. Pluto had never been imaged. Mercury had been critically under-imaged. Only 40% of its surface was known. Uranus had never been imaged. And so all of these wonderful firsts, giving us glimpses about things and informing us really what the solar system is really like. And it's one of these great truth is stranger than fiction. Um, it's wonderful to see. I just love it. Majid, do you remember these ones?
For the Mercury, I should confess no, unfortunately, because I don't know. I should confess that, Venus, yes, but Mercury, I didn't follow up, honestly, with you. I should confess that all the news related to the Mercury. I don't know why, but some planets, I'm more interested to some planet like Venus, like Pluto, like Uranus, but for the Mercury, no, unfortunately, I don't remember. I should confess.
Well, that's okay. I mean, you don't want to forget about Mercury. It is, of course, the first
Oh,
one. But as mentioned, it's interesting to note that even though it is much closer, it's still very hard to get to.
yes.
And, Venus is hard to get to in its own way, too. Of course, that one's not one of our items for today. So we have Pluto, we have Mercury, we have Uranus, all being imaged or well or better imaged for the first time. And Messenger, I do actually remember everyone getting really, really excited for Messenger because so much of Mercury's surface was unknown. The question of what would it find, and Messenger data is still being used to assist with upcoming missions, like what might be in the news later if we get to that one. So I suppose I should probably go to the next item and get our last This Week in Space and Astronomy History. So moving up in time, but going back out to the icy solar system, there is one other surface that had never been imaged by any human cameras or any human eyeballs that we were going to cover. January 14th, 2005, for the very first time, the Huygens probe started to descend into the atmosphere of Titan, the very famous Titan descent. So this is all the way out at the planet Saturn. And this happened due to the Cassini-Huygens orbiter. And of course, the Titan probe was dropped from that orbiter and arrived at Saturn. And of course, came into the atmosphere. And the actual descent was January 14th, 2005, 11:11 SCET, and it started dropping from 32,000 miles-ish, or about 60,000 kilometers, dropping away from the Cassini-Huygens spacecraft all the way out at the incredible distance of the planet Saturn, dropping towards the atmosphere, the actual atmosphere of the moon of Titan. And they did not know what they were going to find. The speed of the probe relative to Titan, 12,000 miles per hour, 5.4 kilometers per second. And at that time, we had 1 hour and 7 minutes signal travel time from Titan all the way back to Earth. So every signal we received from the probe had already happened an hour and 7 minutes ago. If the probe died, it was too late to do anything. So you have this incredible time delay that we see out in the outer solar system. And of course, 2:25 a.m., radio astronomers actually could detect the probe's entry into Titan's atmosphere. So radio astronomers are great. And of course, 4:34 a.m. PST, about 2 hours later, the probe estimated landing time because you couldn't really exactly tell with all those uncertainty factors. Finally, another 4 hours almost later, 8:19 a.m., the first science data arrives. Can you imagine being part of that mission and waiting for 6 hours after the radio astronomers saw it for your probe to finally send you a signal? You would have been absolutely eating your fingernails, I think, or whatever nervous people do, pulling your hair. This is the number one, the one and only spacecraft that has ever landed on Titan. The Cassini-Huygens mission was an amazing success. And of course, in 2005, the dropping of the probe onto the surface of Titan was a real game changer for absolutely everyone. Just as a little aside, the Cassini-Huygens orbiter and probe mission launched together in 1997. It took until 2004 to actually arrive at Saturn. So in terms of comparisons to journeys to Mercury, it was pretty straightforward. The mission completed operations all the way up until 2017, September 15th, 2017. And the release of the Huygens probe didn't stop the orbiter, right? So the orbiter was able to keep going. So this has been a wonderful mission, and for more than a decade, the Cassini spacecraft has sent us back just absolutely jaw-dropping pictures of Saturn, its moons, its rings, and of course, Titan, the mysterious moon with an atmosphere. And this is a big deal because there's not a lot of stuff in our solar system with an atmosphere, especially not a thick one. But this atmosphere is nothing like what we've seen other places. It's nothing like the atmosphere of Earth. It's nothing like the thin, tiny atmosphere of Mars. And it's absolutely nothing like the atmosphere of Venus. This moon has an amazing atmosphere that's incredibly cold. Methane runs like rivers. So methane actually is a gas on Earth. It runs like water on this moon. We have a methane sea, methane ice, gas, and there's possibly even liquid water somewhere under there. Now we think that where the probe landed, there might even be a case for alternate biology or some kinds of life. They didn't find any though. Now, the images from the descent are spectacular. If you haven't seen them, please go to the European Space Agency's Huygens probe area and look at the images that have come back. The first image that came back was absolutely iconic. It looks like it's looking out onto some sort of rocks, but you have to realize that at that temperature, that extremely cold temperature, what we have on as water or liquid or gas on Earth actually is rock and solid surface on Titan. So the Cassini-Huygens mission was a real boon for astrobiologists. They had a ton of fun, and they're still having fun. Everyone has fun thinking about Titan, including science fiction writers, I might add. There's a lot of wonderful science fiction about potentially what you might be able to do with Titan's atmosphere and surface. But this landing meant that we didn't have to speculate about the surface of Titan. We could see through the thick atmosphere and actually look where and see that there are lakes and seas filled with liquid hydrocarbons. We could see liquid hydrocarbons, and astrobiologists can try to figure out what that could mean for extremely cold forms of life that could develop. Cassini-Huygens also revealed that Titan could have reserves of liquid water, just like Europa, Jupiter's moon, trapped somewhere beneath its frigid surface. So if you go down far enough, perhaps there's some heat there. This is an amazing find, and of course, in a really, really fun mission. And it opens up our eyes for all kinds of habitable environments, not just on Titan, but maybe even other locations in the solar system or on exoplanets. Now, during this event, um, we also had the Cassini orbiter witness all kinds of interesting things. There were icy plumes erupting from Saturn's small moon Enceladus, which I believe I'm pronouncing wrong. But I'll take corrections in the comments. The Cassini spacecraft actually flew through the icy plumes and was able to find evidence of saltwater and organic chemicals in that material. So could habitable environments exist there too? So Cassini had a tremendous amount of successes, which we will not be able to go over in this episode all in. But with the primary mission being completed in 2008 and extended operations being completed in 2017, now we just get to work with the spectacular data collected and hope that more missions to Saturn and, well, the rest of the icy solar system all come to be. Now, understanding habitable potentials is in the solar system is very, very interesting, but it also goes to sort of show just how different other planets are from our own, still very, by comparison, habitable Earth. um, so very, very fun stuff. One of my favorites. How about you, Paul?
Yeah, so interesting. I remember I was in Montreal at the time that the data started coming back in, and I was supposed to be at work, but I was actually, surreptitiously on my computer looking at the images as they came in. Interestingly, um, there were two cameras on the Huygens probe, and one failed. It was meant to capture both sides as it came down, and they
Yep.
only got the data set from one side. And they didn't know that until after uh, the mission was effectively over because the radio lag from Saturn. But I think if you take a look at what they found on Titan with the Huygens probe, and then mix that up with the Ingenuity helicopter on Mars, there's a big mission coming, and it's the Dragonfly mission, which is to put an 8-rotor helicopter, I guess, on nuclear powered or from a nuclear battery, put it on the surface of Titan, and fly it around for a couple of years. And
Yeah.
that mission's coming, and I think it's launching in 2028. It'll get to
Yeah.
Saturn around 2033. That's very exciting. And
Oh, yeah.
the exobiologists are losing their mind on that one. So very exciting. And Saturn is, it's not just the best planet to look at in a telescope. It is just an amazing system in of itself.
Absolutely. And all of our stargazers should make sure to look uppity at Saturn as much as possible in the next month because you will see Saturn's rings, or you will not see Saturn's rings in the month of March because we are going to have Saturn tilted with respect to Earth just in a way to line up its rings. And if you've been watching Saturn through binoculars or a small telescope, you can see the rings usually. but you won't see them when it's exactly aligned with us because it's so thin. It draws just the tiniest little black line across the surface. And it looks to humans on Earth like the rings have disappeared. And that will go on for about a month-ish. So very, very exciting Saturn stuff happening all over.
Interestingly, and this is a plug for the observatory calendar, if you pick up your AICO calendar, you'll see in the month of September, we have a comparison of Saturn's rings now and when they're sort of at maximum. And it also notes the date for the minimum, the rings being edge on. So I would encourage you all, the money goes to the observatory, and it's a great calendar.
Excellent. Well, that'll go in well with our reminders. In the meantime, Majid, do you
Yes,
have any Titan
for sure.
favorites?
Yeah, for sure. Because Titan is different than the Mercury right now for me. It's because, as you know, looking for a life everywhere, outside of the Earth is a very, exciting investigation for everyone. Everyone is somehow interested to see if there's any life or any, let's say, living creature somewhere outside of the Earth. And for sure, as you mentioned, Titan is one of the or was or still is, I think, is the candidates for the life. So when they send the Huygens to the Titan, the Huygens has two instruments. One of them was a gas chromatograph, and one of them was a mass spectrometer with the aerosol collector. So what they did, I remember that thing, is that they try to, because the surface, as you mentioned, there's gases there, but the gases are mostly in the liquid form, not in the gas form. So what they did, they heat up those surfaces to generate gases. And after they, let's say, analyze gases by the mass spectrometer and also by the gas chromatograph to see if they can find any track or traces of the, let's say, organic gases, which could, show that, okay, there's any, let's say, life out there. Something else which they did, which was very interesting, is that they had the aerosol collectors, because they said, okay, maybe there are some traces of the life as aerosol, something in atmosphere or in the sea. So what they did, they filter all those gases, and after they collected those aerosols, and after they heated up those aerosols and they transformed them to the gases, let's say, and after they also analyzed those gases to see if they can find any traces of the life. And as far as I know, they couldn't find any traces of the life on that time. And therefore, the hypothesis of the finding, some kind of the life on the Titan, somehow, let's say, not rejected, but went to the shadow.
Yeah, it's a really interesting. I mean, of course, they do find hydrocarbons, but as you say,
Yeah.
nothing definite.
Yes.
And of course, it would be nice if we had some like little creature just walk into the camera and wave at us, so we would know. But that hasn't happened yet. It's all been subtle, very subtle clues,
Exactly.
like liquid hydrocarbons and such.
Yeah, maybe viruses, maybe something like a viruses, kind of the life, maybe not the, let's say, microbacteria, but most probably something like the viruses or something like that, maybe. Or some, let's say,
Absolutely.
complex, let's say, chemical, let's say, complex chemical, let's say, molecules also could be a good clues regarding, finding life or finding, another creature in the Titan. But till now, as far as I know, they couldn't find anything.
Well, they do, yeah, as you say, they do find clues, but nothing
Yeah,
definite on any of the planets. Otherwise, we would definitely have heard about it, and that's something that we do like to remind our public every once in a while of. If we had found anything, scientists would absolutely be going crazy, and you
for
wouldn't be
sure.
able to get us to stop talking about it.
Exactly.
All right, folks, let's go ahead and get to the halfway mark. We're about halfway through the show, so it's about time for me to remind you that you are listening to York Universe. We're broadcasting live from the Allan Carswell Observatory located at York University in Toronto, Ontario, Canada. For any extra questions, or if you have anything you'd like to look up, past episodes, the archive, in-person tours, or if you just like to maybe go and click on that donate button or buy a cool calendar, as Paul said, all of that and more can be found at yourq.ca/science/observatory. Tonight, You're listening to Elena, Paul, and Majid, and we just got done talking about all kinds of wonderful firsts out there in the solar system and their associated flybys, I should say. If you are, of course, listening to this as a recording, you can always find out more about the associated OPV online public viewing by going to that same website and clicking on OPV or going to the YouTube channel for Allan I. Carswell Observatory. All right, so coming back to the show, we have a couple announcements here tonight. This is a little reminder for all of our listeners. The Observatory fundraiser that was running in December and the January, first part of January, is now done. So a huge thank you to everybody who donated to the Observatory. We actually got very, very close to our goal of $5,000. So all of the raffles have been drawn. A winner has been chosen. So the supported observing raffle, the private tour raffle, and the super swag raffle have all been drawn. The winners have been chosen and notified by email. So if you were a part of the cool raffles, congratulations to our winners. And if you missed them, don't worry, you can still buy all of the awesome swag and visit the observatory on our regular tours, our regular Wednesday tours, which are starting up this week in 2025. So great stuff. And of course, in other news, and this is going to relate to the second half of our show, the wonderful Astronomer in Residence program of 2025 is opening at the end of this month, January. So that means that if you would like to consider applying, or if you plan to go out to Killarney Provincial Park in Ontario in the summer of 2025, you'll be able to follow along with our Astronomer in Residence program. Astronomers out at Killarney Provincial Park giving wonderful tours and providing events all summer long, and we even do some live streaming with them sometimes. And of course, Majid, this is one area that I am very glad to have you here on the show for, because you were an astronomer in residence just this last 2024. So I thought maybe I would start off by asking you to maybe just describe your astronomer in residence experience for perhaps other astronomers who might be listening and interested in applying.
Yeah, for sure. At first, I should say thank you, Elena, to give me that chance. Because I remember when I was going to register for the astronomy residence, it was a little late, honest with you, because one of my friends, Dr. Rafi Ali Reza, introduced this program to me and said, okay, I think it's a good program for you and you will like it. And after when I went through it, I said, yes, for sure, I love it. And after I contacted you, and it was a little late, but you were kind, and could find a sweet spot for me, and I really, it was a great opportunity for me to be there for something like 6 days, or let's say 6 nights and 6 days also, being away from let's say city, and be in the very beautiful, nice, let's say provincial parks, dealing and talking and seeing very interesting and amazing people, helpful, nice people, as well as getting the chance, let's say, to be with the night sky, beautiful night sky, and for sure 2 telescopes out there. So I really I should mention that I really have lots of great experiences and memories from them. Would be, if I'm going to categorize it, for sure, one of them would be the nice nature, beautiful nature out there. The other one would be the sky. The third one would be all the facilities. There are lots of good facilities out there, which I encourage people, if they are interested to do any kind of the amateur astronomical activity, they could use those facilities out there. I also get a chance to be with amazing, nice park staffs, and as well as visitors. That one also would be a great opportunity for me. And also I get a chance to do some astrophotography, as well as doing a little, I didn't get a chance because it was a little intense, to do some study or continues my previous studies regarding measuring the air turbulences, and looking for a simple way, a simple method to see if we can measure those air turbulences using the amateur telescopes and amateur equipment.
Yeah, and of course, if anyone wants to follow along, Majid does have a blog on the Astronomer in Residence program. So it's the same website we've been telling you throughout the show, yorku.ca/science/observatory. And then you just go to /air, AIR, and or click on Astronomer in Residence. And in the Astronomer in Residence blog area, you'll actually be able to see some of Majid's wonderful astrophotography. I know you had a great picture of the telescopes, and you have some really wonderful images of the sky as well. And the sunspot picture is great. You did do the
Yeah.
solar filter.
Yes, because it's for sure, sun is one of my main, let's say, interested objects, which always, if I get a chance, anytime when I get a chance, I sit somewhere and read about sun. Anything related to the sun could be something related to the history of the sun. Through the history, any culture related to the sun, anything related to the physics of the sun, anything related to the sun-earth connection, anything even related to the climate and the climate changes, anything related to the sun is my subject of interest. So I really love sun. And as you mentioned, there were lots of sunspots, and right now we are near the solar sunspot maximum times. So I think we should expecting a lot of amazing phenomena or amazing, news from the sun. Let's see what we can see. We already saw two. We have already seen two beautiful auroras. I think everyone in Canada these days, or at least last year, let's say. And I'm expecting to have more auroras maybe this year.
Yeah, fingers crossed. I hope that they will last all the way to the summer, and our next astronomer in residence will get them as well.
Yeah.
So just out of curiosity, do you have any tips for science communicators in training that might help them on adventures like yours?
Well, for sure, for sure. I don't know. Something which I should mention is that science is amazing and beautiful. It's not just logic, because some people look at the science as something just logic and something like like the car. Yes, even a car is beautiful, let's say, but science has a lots of beauties and wonders, plus those logic behind it, behind the science. So something which I always try to do is that to show those wonder and beauties, to show that okay, how much those let's say even order could be a beauty. Sometimes we say something is beautiful because those things have some kind of the order, have some proportionality, have some symmetry, and we can find all those symmetry, proportionality, orders in science. Therefore, when we are going to communicate science, sometimes would be nice, or not sometimes, always, let's say, would be great or nice if we could show those beauties to the people and let them enjoy beauty and they connect to the beauty of the science. And for kids, for sure, would be wonders, because science help us to imagine, to think about. It's some kind of it's when we read something, the science sometimes could be like watching a wonderful or beautiful movie. So that wonder also could give us some kind of the joys and some kind of the initiation to go forward.
Absolutely, and of course, it is always nice to be able to share some of the beautiful images from out there in space with the general public, and places like Killarney, and of course our open public tours. That is probably one of the most fun parts, because you get to share all of your favorite exciting facts about the Saturn or Titan or the sun, and having that excitement is really, I think, one of the most fun things about astronomy.
Yeah.
Um,
Do you know something, if I can interrupt you, something which really like about astronomy? Astronomy is a science we can share, we can share it with a 6-year-old person to someone who's 19 years old. So this kind of we can share lots of things in astronomy in a very let's say wide range of the people. We can share something in astronomy with someone who's let's say don't have even any education, And there are lots of things in the astronomy which you can share with someone who has a PhD, for example, in the physics. So there are lots of, there's a potential. There are lots of knowledge, there are lots of beauties, there are lots of wonders in the astronomy, which I think can share with everyone, let's say. It's different
Oh
than
yeah.
chemistry or, for example, something like mechanics.
Well, I would say you probably can do it with chemistry too, but it is particularly easy with astronomy because
Yeah,
of all of our beautiful images that we can make.
yeah, exactly.
Exactly. So do you have any current favorite sort of astronomical event from the last year?
Oh, for sure, too. I think last year was a very rich year regarding astronomical events. We had a couple of, let's say, nice events, let's say. We had the comet last year. We had a, let's say, solar eclipse, especially the solar eclipse one was amazing, as well as the aurora. We had two auroras, two big auroras, let's say. More than, there were more than two, but two of them were very strong and, brightful. And for sure, I have a nice memory from both aurora as well as the sun, the solar eclipse. In the solar eclipse, since it was a great one, we were a team of the four people. We were in the four groups. We were in the four different locations in Canada, and we tried to measure the Earth-Moon distance by measuring the parallax of the let's say moon, just by measuring the contact time, at a different location, and see by having, and also taking the photos. So with the two methods, one of them is measuring the contact times at different location, and the other one is that taking photos of the, let's say, solar eclipse at the same time, but at the different locations. And we try to measure the parallax of the, let's say, moon Earth parallax, and after, by knowing the distance between each other, we try to measure the moon Earth distance. We could do this measurement, and however, we had something like 6% error, but by 6% error, we could measure the moon Earth distance during the solar eclipse. That one was a very nice memory
That's
for me.
pretty good, yeah.
Yeah,
And of course, reproducing some of the older
yes,
methods for calculations is always really fun. Now, we
exactly.
do have one more tiny thing to go through. For the end of this episode, I think we'll just take the last bit and talk about some news happening right now. And I'm going to take the, I suppose, the challenge and see if I can get Majid excited about Mercury.
For sure.
Um,
Sorry to say this thing. I was a little,
all right.
I'm
So,
supposed to be more polite when it's come to say something, but I just
no,
directly
no,
share
it's
my
but
thoughts.
this is the great thing about, I think space and astronomy
Yeah,
because you can share some excitement.
yeah,
So
for
right
sure.
now in 2025, in January, just a few days ago, on January 8th, the ESA-JAXA Bepi-Colombo mission flew past Mercury for the sixth time. This actually successfully completed the final gravity assist maneuver to do what Paul's mission did so long ago and to actually get into orbit around the planet Mercury. Now, it's not there yet. It finally completed the last gravity assist maneuver. And having completed that maneuver, it will finally reach orbit, full orbit in 2026. So we still have to wait a whole year. But it just flew a few hundred kilometers above the planet's north pole. And Mercury, the closest planet to the sun, has, and I am not kidding, icy, ice, water, ice in the craters in
Wow.
permanent shadow on its north pole. How cool is that? In the news right now.
For sure, it's very cool. You can't
It's
miss.
very, very
Very,
cold.
very, very, very cool.
And the reason it can have this is despite being incredibly close to the sun and having a very extreme situation, the planet Mercury still has some craters that never receive sunlight at its poles. And never getting any sunlight and not having any atmosphere means that it can stay very, very cold. So somehow, some amount of water must have gotten at least Mercury distance to the sun and gotten in those craters. So it is getting very, very interesting. After flying through Mercury's shadow, Bepi Colombo's monitoring camera, MCAM-1, got the first close views, and there are some lovely, lovely pictures online from the European Space Agency right now. And if you haven't heard the corresponding discussion about water ice in some of the moon's crater, and I mean the Earth's moon's craters, it's very, very interesting because it's showing us that even close to the sun, water actually can survive as long as the sun doesn't hit it. So in craters and regions that are never exposed, we can have water. We can have one of the most valuable resources that we know of on something as extreme as Mercury.
Right.
Any final thoughts, Paul?
No, but it is fascinating. And, I think water is one of those things that water ice is one of those things that no matter where we go in the solar system, we find it in unexpected places. We find it, in the poles of the moon. We find it in the poles of Mercury. We find it under the surface of Titan. We find it in possibly in the moons of Uranus and Neptune with Triton. So water seems to be not just a great general purpose solvent, but kind of the most available thing out there.
It is much more common than original, I suppose, estimates led us to believe. And if you've ever taken a beginning astronomy class, one of the first things they tell you is that there's a water line in the solar system, and that the water inside that line is going to be evaporated by the pressure to the sun. And that's true, unless it's hiding inside an interesting crater, like some of these. So Majid, have I convinced you about Mercury?
Yeah, I really, it was a really interesting, news. However, I could imagine that it's possible because the outer space is very cold. It's more than minus 20 degrees Celsius. So if there isn't any atmosphere or if there isn't any, direct sunlight, there could be a possibility of having water, even freezing water, I mean ice, in somewhere like Mercury is possible. Yeah, it could be possible. But it's very interesting doing the news for me also.
Absolutely. And as you say, very, very cold. Mercury's equatorial range areas range from about negative 170 Celsius, or that's negative 170 Fahrenheit at night, all the way up to 420 Celsius or 790 Fahrenheit during the day. So if you can imagine, Mercury is this very extreme area. The places that don't get any sunlight, they're not getting any warmth from the sun, they're going to stay well below freezing.
Yeah.
All right, very, very fun stuff. Um, so I think we'll take any last thoughts on the planet Mercury. Of course, we haven't covered too much about it other than it's very, very hard to get to and it goes from hot to cold. I will just note that despite having the closest distance to the sun, of course, Venus still will beat out Mercury in terms of hot surface temperature due to its extremely active greenhouse effect from its very, very thick atmosphere. All right, so I'm going to take a little moment to thank our special guest, Majid, for coming along tonight on this special York Universe broadcast, first one of 2025. It's been very, very exciting, and a huge welcome to Paul Mackin for joining the York Universe crew. We'll go ahead and thank everyone for joining us tonight, and we're going to have a little bit of a final sorry. Final sign off. I will go ahead and end there.
Sure.
Everyone, you have been listening to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. The hosts this evening have been Paul Mackin and myself, Elena Hyde, with special guest Majid Najib. And of course, we have lots of ways you can get in touch with the observatory, York U Observatory, and Allan I Carswell Obs on either Instagram or Facebook, as you wish. And you can check out our website for show notes, content updates, and of course that very important donate button over at yorku.ca/science/observatory. Thanks for tuning in, everyone, and clear skies, and have a very, very good night.